Good evening, everyone. A pleasant election day. This is the group one, and now we will going to discuss the assigned topic to us, which is all about the chapter three, specific issues in science, technology, and society. So specifically, it is all about the nano world. For the introduction, we are very familiar with the concept of getting raw materials or bringing them together in an organized way and putting them together into a recognizable form. This is our role in the society, and we have performed it well for hundreds or a thousand of years. So here we can say that construction is definitely not a new science or a technology itself. In the same vein, nanotechnology is not a new science and it is not a new technology either. So to further expand this particular word or nanotechnology, Ma'am Corazon will going to take over.
So these are the topics that we are going to discuss. First, what is nanotechnology? How do properties change at the nanoscale? Various uses of nanotechnology, concerns on the use of nanotechnology, and what are some careers related to nanotechnology. And the last is the status of the use of nanotechnology in the Philippines. So based on my research. So, like for example, in a glass of water with different colors, the colors, the color looks red, green, or blue, or any colors that you are going to present. The color looks with that color because of the nanoscale. So it is the nanotechnology that changes the colors, the sizes, the spaces, or anything, or in any substances. Um, like for example, the doctor are working on ways to use nanoparticles to kill or to fight cancer cells. So nanotechnology has something to do with us. So it can help us in many ways in our areas of our lives. So what is the nanotechnology? Nanotechnology involves manipulating matter at unprecedentedly small scales to create new or improved products that can be used in a wide variety of ways. So it is a small particles that can be used in many ways, like for example, in cosmetics, medicines, in packaging, or in any food. So it is the nanotechnology manipulate, and it is to improve the products or to preserve. So nanotechnology refers to the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. So nanoscience and technology. Nanotechnology employs the study and application of exceptionally small things in other areas of science, including material science, engineering, physics, biology, and chemistry. So nanoscience and nanotechnology involves the ability to see and control the individual atoms and molecules. So everything is made up of atoms or the nanotechnology. The food we eat, the clothes that we are going to wear, the building and houses we live in, and our bodies. So that's our the compose of nanotechnology in our bodies. To continue.
Okay, nanotechnology and nanoscience. The concept started in December 29, 1959, when physicist Richard Feynman discussed the method in which scientists can direct and control individual atoms and molecules in a stock. There's plenty of room at the bottom. During the American Physical Society meeting at the California Institute of Technology, next slide, please. So how small is nano? How small is it? So let's discover nanotechnology. How is it small? How is it different and new? Here are the key ideas. First, the nanometer is extremely small. So at the nanometer scale, materials may behave differently. And we can harness this new behavior to make new technologies. So it is extremely small and it behaves differently. And through nano, we can harness new behavior to make new technologies. So why should we study nano or why nano education? The advantages are it's fun, of course, exploring with this kind of um, topic, we will know more, better, and will understand more process of making new technologies. So it's fun. It breaks down disciplinary boundaries. It's cutting edges and relevant to future jobs and careers. Of course, as the modern science and technology develops, so we should know how do we process the raw materials and how do we make new inventions through technology. So education about nano is very important. But there are still drawbacks. Um, it is not inherently interesting compared to dinosaurs, of course. So below visible threshold, younger kids have problems visualizing. So it can be more difficult to younger kids to understand, and we can have unexpected properties. Then, so nanotechnology and nanoscience has an interdisciplinary endeavors. When we study nanoscience and use nanotechnology, it can be in chemistry, it can be in biology, in physics, in engineering, in medicine, in biotechnology, in material science, and even in the information technology. So it has really a wide scope and a very wide use, the nanoscience and nanotechnology. To continue,
What is nano? We can see in the screen this is about prefixes for SI units. Prefixes, symbol, meaning, and notation. Next slide. How big is a nanometer? How big is a nanometer? So in the time it takes to read this sentence, your fingernails will have grown approximately 1 nanometer or just 1 nanometer. Next, if you could paint a teaspoon of paint 1 nanometer thick, how much it would be cover? If you could paint a teaspoon of paint 1 nanometer thick, how much the area? To cover a football field with a 1 nanometer thick layer of paint, you would need just a 1 teaspoon of paint. Next reporter.
Mamping. Mag-proceed na lang siguro yung iba.
So we might wondering if scientists or did scientists create banana or not. So if I were going to ask you, do you think ba science create nano or not? Can anyone answer it?
No.
Yes, it's a no. It was already in nature po. So as you can see here on the screen, we have here the three figures, which is the first is a centimeters to micrometers. The middle one is the micrometers also. And the third figure shows the nanometers. So hindi scientists yung nagre-create ng nano. It's already in nature itself. Proceed please. So another evidences, centimeters to micrometers, micrometers, and nanometers. Proceed. Smallness leads to new properties, sometimes gravity losses. So sobrang liit ng mga nanometers minsan yung mga gravity nawawala na din sa sobrang liit nila. So meron tayong tinatawag na nanometers na mga maliliit and meron din tayong mga lalaki. It depends on the scientists themselves po. So for the next slide.
So, a pleasant election day to all. So this is my part. So the similar of half stone printing. So this half stone printing, this is the a printing in a simple term. So this used as a pixelation or a dot or yung pattern sa digital image. So itong half stone printing, it is a technique. Ito ay used to traditional printing to produce continuous tone of images. So katulad ng mga photographers or illustrations such as a series of small dots. So these dots can be vary. Merong mga the spacing to create the illusion or the different shades of gray or the color may be viewed from a different distance. So the digital images nito is, ang concept nito is pixelation, katulad siya ng pixelation. So instead of using physical dots, the digital images are made up of individual pixels. Katulad niya nakikita yung maliliit na mga dots. That is made up of individual pixels. So yan yung smallest unit of visual information. So each pixels can have a specific color or the shade. So when you combine in a grid, they are form the overall images. So katulad ng half stone printing, the arrangement of sizing of the pixels determine and perceive the shades and colors in digital terms. So in simple terms, this is the pixelation ng digital images, though it can be compared sa half stone printing. So kasi both of them is involved in using small elements or tinatawag na dots or yung mga pixels. So this to create the appearance of various tones and color of images. So next slide, please. So how to view the nano materials. So ito ay isa sa mga materials to how to view the nanomaterials. So first is the electron microscope. So this was first developed by the German engineer Ernst Ruska and Max Noll in 1930. So these used as a particle beam of electrons to illuminate a specimen and create highly magnified images. So itong electron microscopes in the yield such a greater resolution than the older light microscope. So they can obtain magnification up to 1 million times, while the best light microscope can be magnify an image on only 1,500 times. So in a simple terms lang siya, the microscope, ito yung powerful tool no na ginagamit ng mga scientists to see a very tiny things like mga cells, yung mga particles, yung pinakamaliliit na hindi na makikita ng ating mga mata. So ito yung mga greater details na great details than the regular microscope. So instead of using a regular microscope, ang electron microscope kasi it is used as a beam of electrons, so which are tiny particles. So to light up the object being studied, these electron beams allows the scientists to create a highly magnified image of the specimen. So making it possible to see a very small detail. So to compared sa mga the older light microscope, itong electron microscope kasi they can provide much a greater solution, meaning they can show a finer details, yung pinakamaliliit talaga, and also detailed, so they can magnify the image up to 1 million times, or while the best light can be microscope or can be only magnified up to 1,500 times. So next. So next is this atomic force microscope or AFMS. So it gathers information by feeling the surface with the mechanical probe. So Gerd Binig along with Calvin Cotte and the Christoph Gerbert developed the first AFMS in 1986. So itong AFMS, ginagamit ito naman ng mga scientific instrument that help us to study or para maintindihan natin yung mga maliliit na bagay katulad ng mga atoms or molecules. So they work by using the special probes para ma-feel or touch the surface of the object. So when we examine this, the probe move very carefully lang across the surface. So this making a small and precise movement to scan or to gather information. So ang first na develop by the AFMS was yun nga si Gerd Binig and then si Calvin Cotte and the Christoph Gerbert in 1986. So they came up with this idea to use a mechanical probe to explore and study this tiny object. So itong probes, ito ay sensitive masyado, no? So it can detect even the smallest detail or irregularities of the surface. So these probes move along the surface. So it experiences forces between the atoms or molecules. So yung object or the probe itself, or they measure these forces. The AFMS can be created on a detailed image of the surface. So like using our sense of touch to understand the shape, the textures, or the properties of the object. So ang mga movement ng mga probes nito ay masyadong precise and controlled. So it can scan the surface in a systematic way. So by gathering the information to point by point to create a full picture. So yung mga scientists, this allows them to study the structure or the properties of the materials at the atomic or molecular level. So to shorten ko na lang kay masyadong mahaba yung sinasabi ko. So atomic force ng microscope, ito yung talaga ay special tool na ginagamit as to feel or to scan the surface of a small object. So, nadedetect nito ang maliliit na mga detail, or it can help the scientist to learn more about the things he wants or she wants to learn at a very small scale. So next. Next is the scanning tunnel microscope, or STM. So among numbers of instruments that allow scientists to view and manipulate nanoscales, particles, atoms, and small molecules. So it earned its inventors, Gerd Binig and Heinrich Rocher, at the Nobel Prize in Physics in 1986. So ito naman ang STM, ito naman ay special tools din, no, na ginagamit din ng mga scientists to see or to control that are extremely tiny, like particles or atom and a small molecules. It was created by these persons, George Binig, Heinrich Rocher, and yun nga, nanalo sila sa Nobel Prize in Physics in 1986. So how the STM works. So by using a very sharp thing that is maliliit masyado, na-detect nito ang individual atoms on the surface. So ang tip niya nito, it brought very close to the object being studied without actually touching it. So it creates a tiny tunnel of electron between the tip and the object. So by measuring the flow of the electron in the tunnel, the STM can create an image of the surface. So with the STM, ang mga scientists, they can see or they can manipulate things in nanoscale. So which mean they can study and control objects that are incredibly small. So natutulungan sila to understand the properties and behavior of these tiny particles and atoms, so which is important for many fields katulad ng mga science or other technologies. So itong scanning tunnel microscope, ito yung mga special tools that let scientists see or can manipulate things that are extremely small. So next, ito yung mga example ng mga special tools. These are the optical microscope. Ito yung ginagamit sa mga lab ng mga STEM students. These are the microscope they use to see the cells. The scanning electron microscope, ito naman for specific things for their studies, and the transmission electron microscope. And the next, ito yung mga maliliit masyado na mga things they want to see. Ito yung sinasabi na they can see things na to feel the surface. Ito yung to scan more deeply. The scanning electron microscope and transmission electron microscope. Ito yung maliliit masyado na hindi na makikita ng mata natin. That's why they use the special microscopes. Okay, I will end my reports here for the next reporter to continue.
So we have here A Boy and His Atom, the world's smallest movie. So the process used to create the movie made from atom. So it is a stop motion animation created using a scanning tunneling microscope. So which is a tool that allows scientists to manipulate individual atoms. The movie depicts the motion of a boy playing with a single atom and was created by arranging individual atoms to form images and then taking series of photographs. So it can be viewed by magnifying it 100 million times. Next. The nanotechnology, business and practical applications, where the Philippines is and where it should be. So we have here the nanotechnology game changes and how small is a nanometer. So nanometer is 10 times smaller than the width of our DNA and 10 times bigger than the size of an atom. So sa nanotechnology game changers, we have examples are nano titanium dioxide powder, cosmetics with nanoemulsions, and 45 nm metal gate silicon technology. Next. So how small is a nanometer? No, nasabi ko yan kanina. Next, please. This one.
Okay, so let's go to the what is nanotechnology? So the NNI or the NNI of United States defines that nanotechnology as technology that meets the following three criteria. So NNI means National Nanotechnology Initiative, which research and development that provides a framework to coordinate nanoscale. So according to NNI, the nano size is approximately 1 to 100 nanometers, which they believe that nanotechnology is the understanding and control materials on the atomic or molecular scale. So this is the design and control at the atomic or molecular level. So bakit nga ba atomic or molecular level? It is because of its small size. So next slide, please. And an NNI vision is the systematic control of matter on the nanoscale level that will lead to a revolution in technology in the industry. So nanotechnology influences three fields. Wait a minute. So again, nanotechnology influences three fields, which is the biotechnology, material science, and the ICT. So for a while lang po, wait lang po. So nano-based approaches are developed to improve the traditional So nano-based approaches are developed to improve the traditional biotechnological methods and overcome their limitations, such as the side effects caused by the conventional therapies. So in material science, nanotechnology is technically an area within material science because it spans the discovery, fabrication, characterization, modeling, and end use of nanoscale materials. So it also influenced the ICT, which is nanotechnology has greatly contributed to major advances in computing and electronics, which leads to a faster, smaller, and more portable system that can manage and store larger amount of information. Next slide, please. So ano nga ba yung dapat maging concerns natin when it comes to nanotechnology? So here is some. Nanotechnology is not a single technology. It may become pervasive. So when we say pervasive, it can spread throughout and can be seen or felt anywhere. In short term, it is influential. So next is the nanotechnology seeks to produce new materials with specific properties. Next, nanotechnology may introduce new efficiencies and paradigms which make some natural resources and current practices uncompetitive or obsolete. So yun nga yung sabi ng kanina ng kasamahan natin na they are very the nano yung mga scientists na nabibilong sa nanotechnology is very ano sa mga inventions, discoveries. So lastly is it may be very difficult to detect its presence unless one has the specialist tools of nanotechnology. Yun yung ni-report rin ng other reporters natin kanina. So next slide please. So kung may concern, of course, meron ding opportunities ang nanotechnology. So yes, but we have to choose carefully. Nanotechnology includes materials and devices which range from the relatively inexpensive and accessible to the very expensive and inaccessible. So yun nga yung mga inventions and discoveries. So next, opportunity is the cost, benefit, and competitiveness. Next, lastly, is the health and environmental risk or life cycle analysis. So next is the nano manufacturing, which will be discussed by the next reporter. Thank you.
So to further explain the nano manufacturing, it involves scaled of reliable and cost-effective manufacturing of nanoscale materials, structures, devices, and systems. It also includes research development and integration of top-down processes and increasingly complex bottom-up or self-assembly processes. So later we will going to discuss the approaches, yung two basic approaches, which are yung top down and yung bottom up. In more simple terms, nanomanufacturing leads to the production of improved materials to new products. So dito na papasok yung sabi ko kanina sa introduction na nanomanufacturing itself is not a new science or a new technology. Parang ine-expand lang or developing, enhancing, and improving the old technology. So next, the two basic approaches to nanomanufacturing. First is a top-down fabrication, reduces large pieces of materials all the way down to the nanoscale. So for example, like someone carrying a model airplane out of a block of wood. This approach requires larger amounts of materials and can lead to waste if excess materials is discarded. So in simple terms, itong top-down nano-manufacturing, ito yung process of developing a particular product from a whole pieces of materials, yung mga malalaking materials. Next. The next approach is the bottom-up approach to nano-manufacturing that creates products by building them up from atomic and molecular scale components, which can be time-consuming. And scientists are exploring the concept of placing certain molecular scale components together that will spontaneously self-assemble from the bottom up into the ordered structures. So, ang kabaligtaran nito ng top-down nano-manufacturing. Kung kanina, yung sabi ko na ang top-down nano-manufacturing is yung mga malalaking pieces ng materials yung ginagamit nila. Dito naman sa mga bottom-up nano-manufacturing, yung ginagamit nila is yung mga maliliit na mga molecular components or mga molecular components yung mga maliliit or mga atomic. Next. So ito yung example of product of nano-manufacturing. Actually, very common to sa atin eh. If we are really into wires or napapansin natin sa mga bahay natin, meron tayong tinatawag na gauge wire. Usually sa mga bahay natin, meron tayong mga ginagamit na 12 to 14, according to my research, 12 to 14 gauge wires. And sa mga appliances naman natin, meron tayong ginagamit na 6, 8, or 10 gauge wires. So as you can see here naman dito sa picture, sa screen ninyo, a 16 gauge wire above, approximately 1.3 millimeters in diameter, made from carbon nanotube that were spun into heads. And the same wire on yung sa baba, it is a courtesy of Nanocom. So next slide will report by the next reporter.
Okay, so within the top-down and bottom-up categories of nano-manufacturing, there are a growing number of new processes that enables nano-manufacturing. Among these are chemical vapor deposition, molecular beam epitaxy, and atomic layer epitaxy. So chemical vapor deposition or CVD, this is a process where chemicals react to produce high-quality films with exceptional purity and performance. It involves the deposition of thin films onto a substrate by exposing it to vaporized precursor chemicals, which then react and form a solid film on the surface. Molecular beam
epitaxy or MBE is a method used to deposit thin films with precise control. It involves the evaporation of atoms or molecules from a source, which then travel in a molecular beam and deposit onto a substrate in a controlled manner. This technique allows for the precise growth of thin films with atomic level precision. Atomic layer epitaxy or ALE is a process specifically designed for depositing ultra-thin layers, typically one atom thick, onto a surface. It involves sequentially exposing the substrate to different precursor gases or chemicals, allowing them to react and form a single atomic layer at a time. This precise layer by layer deposition technique is crucial for applications that require highly controlled film thickness and composition. Processes are just a few examples of the growing number of techniques used in nanomanufacturing. They enable the production of nanoscale structures, films, and coatings with precise control over their properties and dimensions. By harnessing these processes, researchers and engineers can create materials with unique properties for various applications in fields such as electronics, energy, medicine, and more. Next slide po. Um, deepen lithography. Deepen is a process in which the tip of an atomic force microscope is dipped onto chemical fluid and then used to write on a surface like an old-fashioned ink pen onto paper. So deep pen lithography is a nanofabrication method that involves using the tip of an atomic force microscope or AFM to dip into a chemical surface, similar to how an ink pen interacts with paper. The AFM tip acts as a nanoscale pen, depositing molecules or nanoparticles onto a substrate with precise control. This technique allows for the creation of nanoscale patterns and structures on a surface. Nano-imprint lithography is a process for creating nanoscale features by stamping or printing them onto the surface. Nano-imprint lithography is a process used to create nanoscale features by stamping or printing. Yun nga. It involves pressing a template or mold, usually made of a rigid material, onto a soft or malleable substrate coated with a resist material. The mold is then removed, leaving behind a patterned surface. This technique enables the replication of nanoscale patterns over large areas and is a cost-effective method for a mass production of nanoscale structures. Both deep pen lithography and nano-imprint lithography are valuable techniques in nanomanufacturing due to their ability to create nanoscale structures with high precision and control. These processes have application in various fields, including electronics, photonics, material science, and biotechnology. By utilizing these techniques, researchers and engineers can fabricate nanoscale devices, circuits, sensors, and other structures that are essential for advancement in nanotechnology. Next slide po. Okay, so roll-to-roll processing is a manufac- high volume process to produce nanoscale devices on a roll of ultra-thin plastic or metal. Roll-to-roll process is a high volume manufacturing technique used in nanoscale devices on a continuous roll or ultra-thin plastic or metal. This process involves feeding the flexible substrate material through a series and fabrication steps, such as deposition, patterning, and etching, to create nanoscale features. By utilizing large rolls of materials, roll-to-roll processing enables efficient and cost-effective production of nanoscale devices such as flexible electronic sensors and cells. Self-assembly describes the process in which a group of components come together to form an ordered structure without outside direction. Um, in the context of nanomanufacturing, self-assembly refers to the ability of nanoscale components such as nanoparticles or molecules to arrange themselves into desired pattern or structure. Through interactions between the components, such as electrostatic forces or chemical bonding, they organize themselves into predictable and functional configurations. Self-assembly has significant potential for fabricating nanoscale devices such as nanowires, nanotubes, or self-assembled monolayers with precise control over the properties and arrangement. Um, Next slide po. So what's so special about nanoscale? Nanoscale is at which much biology occurs. Many biological processes and structures occur at the nanoscale. Cells, organelles, proteins, and DNA molecules, for example, all operate and interact at nanoscale. Understanding and manipulating these biological components at such a small scale can provide insight into fundamental biological processes and enable advancement in areas such as medicine, drug delivery, and biotechnology. Scale at which quantum effects. At the nanoscale, quantum effects become increasingly prominent. Quantum mechanics govern the behavior of particles and systems at the atomic subatomic levels. Nanoscale structure and devices can exhibit quantum phenomena such as quantum confinement. Excuse me po, open po yung mic. Open po mic yung Miss Gruzo. Okay, so scale at which quantum effects, wait lang po, ulitin ko po ha. At the nanoscale, quantum effects become increasingly prominent. Quantum mechanics governs the behavior of particles and systems at the atomic and subatomic levels. Nanoscale structures and devices can exhibit quantum phenomena such as quantum confinement, tunneling, and quantized energy levels. Harnessing this quantum effect is crucial for developing technology such as quantum computing, quantum sensors, and nanoelectronics. Nanoscale materials have far larger surface area than similar masses of larger materials. So when materials are reduced to the nanoscale, they possess a significant larger surface area relative to their mass compared to larger scale materials. This increased surface area provides unique properties and enhanced reactivity. Nanomaterials can exhibit improved mechanical, optical, electrical, and chemical properties due to their large surface to volume ratio. This property makes them highly desirable for applications and catalysts, sensors, energy, storage, and environmental remediation. Overall, the nanoscale offers distinct advantages and characteristics that make it special and relevant in various scientific and technological domains. Its connection to biology, the emergence of quantum effects, and the unique properties of nanoscale materials open up new possibilities for scientific research, technological innovation, and advancement in fields such as medicine, electronic, energy, and materials. Next reported po.
So in continuation with what makes nanoscale or nanotechnology special, so structures and properties of materials can be improved through these manufacturing processes, such as nanomaterials can be stronger, lighter, more durable, water repellent, anti-reflective, self-cleaning, ultraviolet or infrared resistant, anti-fog, antimicrobial, scratch resistant, or electrically conductive, and among other traits. So, as mentioned earlier, nanotechnology or nanoscale is very beneficial and has many applications. As mentioned here, the different traits of having nanoscale or nano technology, it can really ease in terms of processes of manufacturing, and it can also be very beneficial and very applicable to various domains, as mentioned earlier, and very flexible in terms of other fields as well. Next slide, Bob. So, taking advantages of these properties, today's nanotechnology enabled products range from baseball bats and tennis rackets to catalysts for refining crude oil and ultra sensitive detection and identification of biological and chemical toxin. As I mentioned earlier, it can be very flexible, the presence of nanoscale or even nanotechnology in various fields. So it doesn't just focus on the technological domains, but it is very it really goes beyond that. It also reaches the scales of like in sports and in terms of our resources such as the oil and also the detections of the various energies in our environment. So next slide. So nanoscale transistors may someday lead to computers that are faster, more powerful, and more energy efficient than those used today. So nanotechnology also holds the potential to exponentially increase information storage capacity. Soon your computer's entire memory will be able to be stored on a single tiny chip. In the energy arena, nanotechnology will enable high efficiency, low cost batteries and solar cells. So, um, in shorter term, the presence of nanotechnology and also its strands really can help is not just the dilemmas that we humans often experiences on various fields. For example, in technology, as mentioned here, it can really help our computers, our gadgets, and in terms of functioning well because it gives them the benefit, the push to be more very progressive in terms of giving us more informations that we need, and also in terms of and storing memory. It can be really um, time efficient and also effort efficient because in the end, as we continue to embrace nanotechnology in our daily lives, it can really gives us the ease in doing the things that we do, whether in academically or just in various fields or various things that we do. So next slide, Bob. So here are the correlation between the top 10 applications of nanotechnology for developing countries and the United Millennium Development Goods. So from energy storage production and conversion, agricultural productivity and enhancement, water treatment and remediation, disease diagnosis and screening, drug delivery system, food processing and storage, air pollution and remediation, construction, health monitoring, and vector and pest detection and control. So the presence really of the nanotechnology is way beyond, as mentioned earlier. It's very flexible. It doesn't just focus on one certain field. It goes parang somewhat like it reaches other fields such as health or medicine. It also focuses on agricultural and even um, in like making connections, not just focusing on the things that it can reach because technology nowadays it really evolves. So with the help of our scientists all around, not just nanotechnology, we can really reach and also think of alternatives and solutions for various problems that surrounds us. So next slide and next reporter.
So, good evening, everyone. To proceed, we have here the government funding for nanotechnology in different countries. So basically, the question here is that why we need to have allocated funds in nanotechnology. So another concern kasi about nanotechnology is the price. Nanotech is a very expensive area of research and largely confined to developed nations with strong infrastructure. For example, here we have the US National Nanotechnology Initiative, which is the best known and most funded program, is the National Nanotechnology Initiative of the US. So the NNI was established in 2001 to coordinate US federal nanotechnology R&D. So here it is being indicated that US was able to allocate 1.4 billion US dollar to 1.5 billion US dollar na fund just to improve their country in terms of maybe technology, transportations, or even infrastructure as well. So as we all know, US is a very strong country and they are belong to a first world country. So of course, parang it is really obvious that they are very well known when it comes to the most advanced technologies, first and foremost. So next slide, please. So right here we have the government funding for nanotech in European Commission and Japan Nanotechnology Research Institute. So in European Commission in February 2008, the EC officially launched the European Nanoelectronics Initiative Advisory Council, or what they call the ENIAC. Meanwhile, under the National Institute for Advanced Industrial Science and Technology naman for Japan Nanotechnology Research Institute. So as what we have observed here in the presentation, parang all different countries have certain organization or institution that tries to at least pursue nano education on their country. Of course, it's for them to have a more advanced country. And when we say kasi nanotechnology, it offers the potential for us to new and faster kinds of computers, just like, for example, more efficient power sources and life-saving medical treatments, just like what our report had said a while ago. So next, please. So right here, we have naman the government funding for nanotech in Taiwan, India, China, and Israel. So first, we have here the Taiwan National Science and Technology Program for Nanoscience and Nanotechnology. So sa Taiwan, I mean, they focuses more on the science and technology, while in India they research more. I mean, in India they focus more on research and education. China naman, on the other hand, they developed a national center for nanoscience and technology, and the same thing as well for Israel, which they have developed an organization called the Israel National Nanotechnology Initiative. So next, please. So here, as we have the country of Australia, Canada, and South Korea, the same thing as well for Thailand and Malaysia. So sabi ko nga kanina, all countries have different organizations or institutions that tries to at least educate themselves about nanotech for us to have a more progressive country. And the advantages kasi of nanotechnology I mean, the reason why we have this kind of education in different countries is that it promotes um, various knowledge, just like, for example, sa renewable energies, and it extends as well the limits of electronics and even in the field of medicine. So therefore, I conclude that parang nanotechnology is not just about advancing our country, but it's more on like globalization has something to do with it, since nga we are sharing different ideas with different countries among different nations for us to be able to to have a stable country. Just like, for example, as in here in the Philippines, we are belong in the third world country. So basically, we have to adapt the changes when it comes to modernization of different countries for us to have the same values and the same knowledge when it comes to technologies. So I'm giving the next presentation for our next reporter. Thank you.
Some concerns of nanotechnology: developing a rational cost-effective approach to nanotechnology. Patent situation: U.S. University hold most of the patents, uncertainties, and abuses. U.S. Homeland Security restrictions, export controls, and sensitive technologies. Next slide, please. Possible application of nanotechnology in the Philippines. As you can see, we have an example here of nanotechnology tree. The trunk is the nanotechnology itself, and it gets the power from soil, which is the environment. And the tree produces ICT, semiconductors, health and medicine, energy, food, and agriculture. Next slide, please. Nanotech Roadmap for Tech Philippines, founded by PSCAS RD DOST. ICT and semiconductors, health, biomedical, energy, environment, agriculture and food, health and environment risk, nanometrology, education, and public awareness. Next reporter po.
Okay. The application of nanotechnology to the environment. Next. So here's the major environmental applications of a nanotechnology. First is the water treatment and the purification. Second is the environmental redemption. And then three is the green nanocomposites. And then here is like mga examples ni is like the water treatment is like if ever the inom ka mo sa mga tubig sa nawasa, you can also taste the chlorine. So that will be the water treatment. And then the environmental redemption sama, which is like ng mga in the farm siguro. Hindi ko lang sure pero I think. And then next slide po. Like this, the water treatment of the purification is an nanoscales water filter in the increasing fish water supplies in the product water quality through the effective wastewater treatment. So here, itong ginamba ko ina, like we drink in the water in the nawasa, so we can also taste the chlorine, which is nagapa-clean siya and then naga like nagapa-kuha sa mga viruses and any mga bacteria niya para magiging fresh siya. So next slide. The nanofiltrations for the cleaning water. So next slide. So here in nanofiltration using a partly permeable membranes to perform the separation of nanofilters have been applied to the distinctions in the water treatment for removal of the microbes and the viruses and metals. So atong ginamba ko gaina, amo na ni siya ang mga examples niya para makuha niya ara dito sa tubig or any kinds of so next. Second is the environmental redemptions. So first is the iron nanoparticles. And here na naman is it's all about just environmental um env- environmental problem, which is wait lang po, which is like mga um evaporation for extractions in the terminal depressions and the treatment of nanoredemptions. So next slide po.
Okay, so to further add information about environmental remediation discussed by the previous reporter, aside from iron nanoparticles, there is also titanium dioxide nanoparticles. So titanium dioxide nanoparticles have been used as homogeneous photocatalyst for the remediation of ground and wastewater because of their potential to degrade a wide range of organic and inorganic compounds. Titanium dioxide is inexpensive and has low toxicity. So, photocatalysis using the semiconductor titanium dioxide has proven to be successful technology for wastewater purification. The photocatalytic treatment is an alternative method for the removal of soluble organic compounds in the wastewater. So lastly, under the environmental remediation is the silver nanoparticles. Silver has long been known to exhibit strong antimicrobial properties. Its activity has been enhanced with the discovery that the bactericidal properties of silver nanoparticles are dependent on both their and shape, size and shape. So, silver nanoparticles have been widely used to improve membrane performance for anti-biofouling and to aid in photocatalytic degradation, in thermal response, and electroconductivity. So next slide, please. So let's move forward to green nanocomposites. So green nanocomposites are materials with minimal impact on human health and the environment. This is an improved performance. Nanotechnology is having a huge impact on various consumer products. So nanofibers and nanoparticles are being used to create next generation non-woven materials and ultimately non-woven products for industrial and medical applications. So, for example, is the bamboo charcoal fabric that is made from nanoparticles of bamboo and charcoal. The fiber is impregnated with silver nanoparticles. Next slide, please. Next, there are three possible applications of nanotechnology for the environment in the Philippines. First is the passive nanomaterials. For examples are nanofilters and the green materials. Second is the active nanomaterials. Examples are photochemical reactors, antibacterial materials, and sensors. And the lastly is the nano devices, such as microlabs on a chip and as self-reporting sensors. Next slide, please. So, what are the benefits and applications of nanotechnology? Nanotechnology is helping to considerably improve, even revolutionize many technology and industry sectors. Information technology, homeland security, medicine, transportation, energy, food safety, and environmental science, and among many others. So, let's hear the next reporter to further discuss the benefits and concerns on the application of nanotechnology in different areas.
Good evening, everyone. I will be the one to discuss the benefits and concerns of the application of nanotechnology in different areas. So we have three examples of areas affected by nanotechnology. These are environment, health, and economy. So first, we have the environment. Its possible benefits are improved detection and removal of contaminants, development of beneath industrial processes and materials. So an example of this is the pollution remediation. These are nanomaterials that can be used for water purification, air filtration, and soil remediations. So next we have the concerns. These are high reactivity and toxicity, pervasive distribution in the environment. Um, so the toxicity, these are the release of nanoparticles into the environment that raises concerns about their potential impact on ecosystems, mainly the environment. And next, no nano-specific EPA regulation. So why proper regulation is needed? It is needed because we need to ensure the responsible and safe use of nanomaterials. Next slide, please. So next we have the health. So the possible benefits are improved medicine. So also we have an example of this is the drug delivery. So in nanotechnology, it enables targeted drug delivery, allowing medications to be delivered directly to affected cells or tissues, increasing efficiency and minimizing the side effects. And next, we have the diagnostic tools. These are nanosensors and nano devices that can detect diseases at an early stage and which could lead to more accurate and diagnosis and personalized treatments. Next, for the concern, we have the ability to cross cell membranes and translocate in the body, and no FDA approval needed for cosmetics or supplements. So for the safety, the potential toxicity of nanoparticles and their long-term effects on human health are areas of concerns that need to be thoroughly evaluated. And in regulatory issues naman, the development and use of nanomedicine require stringent regulations to ensure the safety and efficiency of these products. Next, we have the economy. Next slide, please. So we have the last example of areas affected by nanotechnology. This is economy. The possible benefits for this are better products and new jobs. For the concerns naman, we have the redistribution of wealth, potential costs of cleanups and healthcare, and the accessibility to all income levels. So overall, the application of nanotechnology in the economy holds significant potential for economic growth, improved manufacturing processes, and new business opportunities. However, it is important to address concerns related to investment, intellectual property protection, ethics, and workforce skills to foster responsible and sustainable economic development in this field. Next slide, please. Also, we have the social and ethical consideration in conducting research on nanotechnology. First is who will benefit from it, on the other hand, who won't. Second, for whom and what are your objectives for developing your product. Third, how will it affect social, economic, and political relationships? Fourth, what problem is your product trying to solve? Fifth, who will have access to it, who will be excluded? Next slide po. 6, are these dangers involved with its development? In example given, the safety, health, and pollution. How can you minimize them? And lastly, who will own it? How can you assure access to it? So
It is important to note that while nanotechnology offers numerous benefits, addressing the associated concerns and risks is also crucial to its responsible and ethical development and deployment. So that concludes my report.
So
Next
for the
group of
summary, okay, good evening everyone. For the summary to this topic, nanotechnology is an advanced interdisciplinary field that encompasses science and technology that manufactures materials of great help to the improvement of various areas of society, especially healthcare, environment, energy, food, water, and agriculture. It is a field that needs to be explored not only by known experts but also neophytes in order to advance our knowledge of science and technology, and more importantly, to help improve our quality of life. But before we engage in nanotechnology, we need to take into account the social, ethical, and environmental concerns of using such nanomaterials. So, to sum up this topic about nanotechnology, nanotechnology is the study of manipulation of matter at the nanoscale. So currently, nanomaterials are employed for a variety of purposes, including engineering, clothes, sunscreen, home goods, and medicinal applications like as medication, administration, and medical imaging. So while certain applications like sunscreen nanoparticles pose no health risk, others like multi-walled carbon nanotubes may be dangerous if breathed. So the manipulation of matter at the atomic level is called nanotechnology. So the potential for innovation in a wide range of fields, including medical, energy, computers, consumer goods, biotechnology, and information technology is enormous, and it spans practically if every major sectors and several research fields. So environmental health and safety issues, or EHS, should thus be a major consideration in the ongoing in order to avoid creating dust or aerosols that might cause inhalation. We should handle nanoparticles in solution to reduce our risk. So thank you.
And that includes our report, which is about the nanotechnology. Thank you and a pleasant election day.